Joining us this Thursday afternoon in the 8th edition of the AtlanTec Festival. We're fastly approaching the end of the week of what has been a fantastic week of amazing events and world-class speakers. This afternoon is set to be no different. But before we introduce our speaker for the afternoon, I'd like to thank our sponsors for making this event possible. Avaya, Cisco, Fidelity, NUI Galway, Genesis, Galway Advertiser, iTech Skillnet and Storm. They continue to support the festival, and without them this event wouldn't happen. This afternoon's speaker is Gearoid Hynes. Gearoid is CitySwift's head of product, where he defines and drives the product strategy. At CitySwift, Gearoid combines his passions for technology and sustainable transport while building on his experience across academia, multinationals, and other startups. Today, Gearoid is going to share with us how CitySwift are using machine learning to improve bus networks for passengers, cities, operators, and the environment. And I'll hand you over to Gearoid for what is no doubt going to be a very interesting presentation.
Brilliant. Thanks, many, William. We'll just give it a second for my slides to come up. There we go. Okay, so like William said, so I'm head of product at CitySwift. So I've kind of a varied background. So started in academia, then moved on to kind of the multinational space, experience in other startups. But today I want to focus on CitySwift and want to talk to you about how we're using machine learning to improve bus networks. And that's got benefits for a lot of different stakeholders. But before getting into that, I guess a lot of you might be wondering, why should you really care about buses? You know, some of you might have had bad experience with buses. You might think they're slow. You might think they're inconvenient. You know, oftentimes it's a lot easier just to jump in your car. So really, why should you care is probably the critical question I want to answer for everybody. So before diving into the details of, you know, why you as an individual should care, what I wanted to do is take a step back and just look at some of the global issues that are impacting all of us. And these issues relate to transportation as well. So start with around the energy prices. As we're all well aware, you know, energy prices have jumped significantly since the outbreak of the war in Ukraine. This impacts many different areas, but the cost of transportation is a big one. So cars are mainly impacted at the moment because a lot of the public transport. Over time, the impact will spread. Transport. Another issue is one to keep in the back of your mind is around the issue of inequality. In the Western world, the gap between the richest 10% and the poorest 10% continue to grow. So you might ask yourself, why is that important from a transport perspective? The reason that is if you look at the amount of person has to spend on transportation as a proportion of their overall income, much higher for on social welfare on lower income. And as a result, they're less likely to be able to afford a car. They're going to be more reliant on public transport. So if there isn't good public transport service, it can curtail their life significantly. It can curtail the job opportunities they have because they simply can't get to and from work. It can curtail their education opportunities and kind of just leaves them stuck in a rut. So inequality is very important from a transportation perspective. And then finally, there's climate change, which is probably the biggest issue of the three listed. And in the EU and the US, transportation is the largest single source of emissions. So if we just take a quick look at that, for instance, if we look at this study around CO2 emissions in Europe, so the EU 28, we can see that transport in general contributes 32% of those overall emissions. If we break that down further, then we can see the vast majority of that 32% is made up of vehicular emissions. So, and then as it turns out, that is then in turn predominantly made up of car and then to a lesser extent, motorbikes. So if we really want to address the topic of climate change, we all need to have a look at how we move and what our modes of transport are. So if we narrow in a little bit further then, so we've talked about the global issues and we focus a bit on the cities then. So I'm sure, we all understand the transport related issues that cities are facing. And those of us who are based in and around Galway can definitely relate to that. So, there's ongoing transport issues for anyone who's trying to go in and out in Galway. So from a transport perspective, what the cities need to provide is they need to provide efficient transport options for residents to move around, to go to work, to go to shopping, etc. If those residents do not have efficient transportation options, they'll have to resort to private cars, which then in return results in congestion. And as we know, congestion it's really time consuming for individuals. It brings cities to a standstill, and then fundamentally it's just really expensive for everybody. So if we look at urban traffic congestion cost, and cost the UK economy 6.9 billion in 2019, and there's going to be similar scale issues across all of the developed world. There's several options to fix these problems, but the most expensive and the least effective in the long term is to add more roads. And so if we look at the US again as an example, it costs 62.4 million to add 1 mile of highway lane in urban. And then finally, it's a knock-on impact of some of the ones that are mentioned above is around the quality of the air we breathe. All pollution from air pollution from vehicles is a significant problem worldwide, and 9 million people die every year from issues when it comes to air pollution. So all of those city level issues are then further compounded by population growth in our cities. So over the next 30 years, city populations are set to double across the world. So this is going to put really significant pressure on our already creaking transport infrastructure. So fundamentally, what we're talking about here is, what do you want to prioritize your limited existing space for? So creating new space might necessarily be the right thing to do. So what do you want to do in terms of the space that you already have? If we build more roads, it'll temporarily alleviate congestion issues, but we know from lots of different research studies that within 5 years, through induced demand, that would be back to the previous congestion levels. And how is that then going to impact the livability of our cities? And then if we take it one step further then, so I talked about the global issues, talked about the city issues, but then, for every one of us here, there's passenger related issues. And so the most important thing to think about is those passenger issues. And ultimately, everybody just wants to get from A to B in the most efficient manner possible. We all want to have a choice of transportation that's punctual. So like if there's a car outside my house, or then I've got the ultimate punctuality. I can leave my house when I want to. There'll be a mode of transport ready for me, and I can just go on. If you're talking about scheduled services like buses, trains, light rail, etc., so they can't offer that, immediate punctuality that you get with the car, but you get by walking. They can get close to it if they can offer high frequency, but even with that, you have to factor in walks to the stops. You have to factor in wait time at the stop, etc. And then on top of that, we all know some of our public transport often runs late, so which can make it, really frustrating and time consuming. Reliability then is an important one to call out as well. So reliability is all about, does the trip that you're depending on actually turn up? And if you can't depend on your bus, train, Lewis turning up, then it's not going to be a viable option for you when you want to get to a particular place at a particular time. The cost of the transport is also going to be a factor. So not all of your transport options are going to cost the same. And then finally, there's the time. So how long is it going to take you to go to travel door to door? Different issues which heavily influence our choice of transport mode. And the answer you get to each of these is going to vary from city to city and from country to country. So some cities are better set up than others. Some countries are better set up than others. But the good news is that there is a wide range of options available. Again, it'll vary city to city depending on what the city's budgets are. But there are a lot of options out there. And ideally what you'd have is you'd have a mix of options available in the city. The larger ones might have a broader mix to justify, because they'd have a bigger budget and be able to make that infrastructure spend. So whether you're going by heavy rail, underground, light rail, bus, car, taxi, or even looking at some of the micro mobility options that are appearing now, your scooters, or you're looking at active mobility, so you're walking, you're biking, etc. These are all viable transport options. But they all have pros and cons, so it's important then to have a mix of these different transport options in your city. So what we're going to do is we're going to look at some of those options and see how well they kind of fare up against each other. So firstly, I want to talk about the efficiency of moving people. So what we have here is a study by the World Bank for Greater Auckland, and they looked at how efficiently their different modes of transport can move people through your standard 3.5 meter wide city lane over an hour. So we can see that the car is actually the least efficient way of moving people. The bus is better, but the problem is that the bus gets caught up in the traffic, in the car-related congestion. So what's really interesting is the simple solutions, and the relatively cheap solutions of cycling and walking are very effective over short distances. So they're really high throughput. So prioritizing active travel so that people who can and want to cycle and walk is very important. The next option that I want to call out is a thing called BRT, or Bus Rapid Transit. So this is a bus with dedicated measures in place. So in this case, it'll have a dedicated bus lane, and it'll have other priority measures in place to help it move quicker and stop it getting caught up in any of the congestion. So we can see once we've got good priority measures in place, the efficiency and the throughput of a bus is actually quite comparable to something like a light rail system. So the lower ones, like the light rail and the heavy rail, which have the highest throughput, they are expensive. They're very infrastructure intensive, and they have high upfront costs. But overall, once they're in place, they can move a lot of people very quickly. To look at things then from an environmental perspective, and if we look at things from CO2 emissions, so how far can we travel across any one of these modes of transport on 1 ton of CO2? So just by emitting 1 ton of CO2. So again, this is based on research by the World Bank. So if we look at our active travel options, effectively, you can go for an infinitive distance. So there's very little CO2 emitted as you walk or as you cycle. It's negligible. The buses perform very well in this, even in this model, which is using diesel buses and ignoring the electrification or hydrogen buses that are being rolled out at the moment. And then, unsurprisingly, private vehicles are the worst performing option. So which explains, really kind of going back to the previous slide, of why they make up such a sizable proportion of the overall transport emissions. And then, before diving into some of the specifics about what CitySwift do, I just want to talk about the cost side of things. So there's the cost that you as a commuter have to pay for these different options. And these costs, again, are going to vary city to city or country to country. And what we're showing here is some research done out of Copenhagen. And we can see that, again, the car is the most expensive option for commuters to run on a yearly basis. And then your active transport options are unsurprisingly the cheapest. The bus performs out, okay. It's in the middle there amongst the options. But just because there's money out of your pocket, it doesn't actually represent the entire cost of these different modes of transport. So no roads need to be built, traffic lights need to be put in place. So while these costs don't come directly from the commuter, it does come from society in general in the form of taxation. So if we look at the total burden on society for some of these modes of transport that we're talking about, we can see that the active travels society. If anything, some studies have shown that they're beneficial to society in terms of the health benefits, hospitalization, etc. While on the flip side, then driving it has quite a substantial amount of hidden subsidies in order to keep things going. So what we've seen over the last few slides is that buses perform really well across lots of different measures. So whether it's the cost perspective, environment perspective, efficiency and throughput. So this is why the bus is the foundation of global public transport. So buses carry more journeys than metro, rail and tram combined across the globe. So these aren't just global figures. If we look at the UK, for instance, it's the exact same thing. The bus carries more passengers than any of the other forms of public transport put together. So I guess we got to ask ourselves the question, so if buses are so great, why don't people take the bus more often? So the buses definitely have problems. And if we look at what some of those issues are, so we know that 50% of bus users, 66% of non-bus users have the bus kind of as their last resort. If there is no other way they can get somewhere, they'll resort to the bus. If we look at kind of passenger satisfaction levels, so we can see there's dissatisfaction with the journey times, dissatisfaction with frequency, dissatisfaction with punctuality. And this is relatively common. There was a News Talk interview 2 weeks ago, and the amount of complaining and giving out about the Irish bus services that were triggered from just one simple comment by the host was incredible. So common issues, but as we'll see as we go along, they're definitely rectifiable with the right measures. And then if we look in terms of the time that you spend on the bus, so probably as a result of the growing congestion, the growing car dependency, car ownership, we've seen that over the last 50 years that bus journey times have increased by more than 50%. So it's taken longer and longer to get where you want on the bus. So what's the solution? How can we fix this? So what I want to show you today is that let's start at it from the bottom. Let's start at it from the passenger level. So if we can fix the issues that the passengers have to deal with, so the ones that we talked about earlier, that'll have city level benefits, and that in turn will have. So what are the things that we need to fix? So that we're not really expecting everyone to make a sudden switch to buses. It'd be great if they did, but even if we can make bus a viable option for those who want to get the bus, that would be a big step forward. So the questions that we need to help operators, local authorities answer are shown on this slide. So are the routes connecting to the right places? So we might have bus routes all over the city, but are they actually going to the places that I want them to go in an efficient way? How long will my trip take? So is the bus just going to be stuck in car traffic, in which case, I might as well just take the car. Are the trips being run at the key times of day? So how, does it have the frequency that I need in order to get places? Will the bus actually turn up? And if it turns up, how late is it going to be? Is it going to be on time, or is it going to be running minutes late? So before jumping into how we as a company, CitySwift, solve these issues, I want to just kind of give a little bit of background on CitySwift. So CitySwift is nearly 6 years old. It was founded by Brian O'Rourke and Alan Farley. So Brian has an IT background, while Alan's family run a bus company, and he's literally been surrounded by buses since childhood. So Alan was able to articulate, the issues in the bus industry, while Brian was able to take his, his IT experience and try and address those issues. So at CitySwift, we've started with a focus on the UK market, and we've been really successful there. And as a result of Maggie Thatcher's deregulation of the bus industry in 1986, the UK bus industry is amongst the most efficient in the world, and there are new ideas on how to improve the performance, improve the efficiency of the networks. We've been able to help them with that. So from that foundation in the UK, we've then been able to expand to work with transport authorities in the world. And the two big ones we have there are Transport for London and the MTA in New York. And then we've also been working with Transport for Wales. So as a result of this success, we've had rapid growth over the last 3 years. So we have a team of nearly 60 people based out of the Porter Shed in Galway. And as you'll see in the slides towards the end of this deck, we put a really heavy investment on the technology and the R&D side of things. So before jumping into the solutions to those passenger problems, I just want to kind of give you a little kind of sprinkling of what the platform does. And again, we'll go into a bit more detail afterwards. So the key data sources that we ingest into the platform are the AVL from the bus. So that's GPS data that comes in real time from the buses into our system. This is then combined with the schedule information and the ticketing information. So the ticketing information is important to show, the passenger's perspective. So how many people are boarding at what particular stops, what ticket types, etc. So that data is cleaned and joined, combined with third-party data. So with this, we're able to take the raw data and process and analyze it to the point where we're able to help diagnose issues, predict future issues, and prescribe changes to the operators and local authority. A key differentiator for us as part of this is the point listed under predict. So from that raw data from the operators, we're able to accurately predict where passengers are going to and coming from. So this data is like gold dust for operators and for local authorities, as it's really difficult for them to understand this information. So they have to resort to doing things like surveys on the bus, hiring third-party surveying companies to try and figure this out. So what we're able to do is provide them with a scalable and repeatable way to understand what's actually happening with their passengers in their network. So as you'll see when we move on to the solutions section, this passenger movement data is critical too, and it kind of underpins a lot of the solutions that we have. So if we start with, and we return to kind of the challenges for those passengers, and we start with the routes themselves. So how do we ensure that the routes are connecting the correct locations? So there's a few ways we tackle this. The first thing we look at is unfulfilled demand. So where are the areas in the city which should be connected by bus services but aren't? The second thing we look at is where are the areas in the existing network where passengers are having to take 2 buses to get between their locations, rather than having some sort of more direct route to go between those areas. So in this example, I'm going to concentrate on the unfulfilled demand side of it. And with that, what we begin with is we look at that passenger movement data. So we take the passenger movement data from the bus networks themselves, we combine it with event data so we can understand, are there any events within that data that might be kind of skewing things a little bit that we can control for? We then bring in mobile phone movement data and demographic data. So with the mobile phone movement data, it's at a high level, it's anonymized, and the way it works is that it looks at which cell towers are the different mobile phones connected to. So we've got an approximate location from that. And then it looks at how those phones are moving between those cell towers. So from this then, what's generated is an anonymized set of movement data that incorporates all movement across all modes of transport. So we also have high-level demographic data, which is important because it allows us to segment by passenger type. Your commuters are going to have different behaviors to your OAPs, etc. So the key next step then is combining the analysis of that general movement data with the bus-specific movement data on top to identify underserved regions in a city. So can we see where we have general movement flows, but we don't have any flows within our bus networks, and see if there's an opportunity there to identify new routes or where routes should be going. The next step after that, once you've figured out where you want the route to go, is to ensure that you make the route as efficient as possible. So we want to keep those journey times low for the passengers. So in order to do this, we help local authorities and operators identify the areas that would most benefit from bus priority measures. So this could be a new bus corridor, it could be bus gates, it could be as simple as traffic light priorities for buses. And the way we do this is we ingest the data from all of the bus operators in the city, so we can provide that city level view of what areas they need to focus on for these interventions. A critical part of this then, as you'll see across everything, is that we incorporate that passenger information so that we can weight these recommendations then by the number of passengers that will be impacted by these delays. So these bus priority measures can then improve the commutes of those public transport passengers. It'll lower the running cost for operators because the bus is moving faster, so the same bus can do more trips. And it'll reduce the overall congestion for the local authority and across the city. So what we often find is, we'll have cost savings for the operators, and what they'll do with those cost savings is they'll reinvest it into their route. So not only do you get improvements on the route with the bus priority measures, but you get improvements in other areas where they've been able to reinvest that to try and grow the passenger numbers. So once you've figured out where you want to go, you've figured out what priority measures you need in place to make sure that your bus network is moving efficiently. The next thing to try and figure out is how often do you want trips to run along that route? So fundamentally, what you're doing here is you're balancing supply and demand. So based on where we know the passengers want to go along a route, based on how many, we can work out then how many trips do we need throughout the day to service that demand. So there are restrictions then from the operator's perspective. They have a limited number of buses, they have a limited number of drivers. So these can be incorporated into that process of balancing supply and demand. So driver shortage it's one of the top challenges facing operators at the moment, if not the top challenge. So the reason for that is that many drivers didn't return to work after COVID, and others moved to the haulage industry, which also has a shortage, and the haulage industry is better paid. So there was the loss in drivers as a result of that. So, if you've been waiting for a bus over the last year and that bus simply hasn't turned up, there's a pretty good chance that's due to driver shortage issues. This is a bit worse in the UK because of Brexit. There's visa issues for any of the European drivers that would previously have come to the UK. So there's been that's been exacerbated as a result of Brexit. So to help with this problem, we can analyze the planned schedules. So with the limited driver bus resources, what are they planning on running? We can match that up to the passenger demand, the mismatch between the two. So using this information, operators are able to see where the buses might be too crowded and they might need to add additional trips. Or on the flip side, if there's a time of day where there's really low demand along a route, they could potentially take some of those trips and reallocate them to more appropriate times of day. The final step then we need to look at is around punctuality. So how do we ensure that the bus will turn up when it's supposed to turn up? And in order to do that, we analyze the bus movement data to prescribe run times, dwell, and layover. So that's the run times, dwell, and layover that we believe is required in order to have a good level of service for passengers. So what runtime means is runtime is the amount of time it's going to take you to go between the different stops along the route. Dwell is the amount of time the bus has to stop in order to let passengers on and off. And then layover is the amount of recovery time that you need at the end of each trip to account for any sort of, kind of day-to-day volatility that might happen along the route. So it's a bit of recovery time fundamentally. So it's critical with these different values that they're precise, because if you give too much time, that means that it's going to cost the operator more money because that bus needs to be on the road for longer. The driver is going to be stuck waiting at a bus stop because he's got all this time and he's driven to a stop. He's just going to have to sit at the stop and not move until it's time. And yourselves from a passenger perspective, there's nothing more frustrating than being stuck at a stop when the bus isn't actually moving when it could be. Conversely then, if you have too little time, the bus will always be late. The driver's going to be under pressure and will have to speed and, might be taking some risky maneuvers as they overtake, other road users. And the passengers won't be able to rely on that service because it simply doesn't turn up when it's going to say. So that's why we're able to provide those optimized runtimes, dwell, and layover as part of that overall optimized timetabling process. So what you've seen in the previous steps are how you go about kind of optimizing the timetable and optimizing a route. But the reality is things don't always go as planned. I mean, you need, there might be unanticipated issues. So for that reason, you need to have that ongoing monitoring of your bus network, and it's really crucial. So we've got another product called Swift Metrics, which helps with this. So if there's any unanticipated roadworks, breakdowns, etc., so the people using Swift Metrics, so the operations team, are able to monitor what's happening, do a root cause analysis, and kind of make short-term adjustments as a result of that. Then in parallel with that, from a planning perspective, the people who are creating the schedules want to monitor how the existing schedules are performing. So they, if they have to make tweaks in the forthcoming schedule, etc., they have the information to do that. So Swift Metrics enables this to happen. So it's really quick and easy reporting on network level data. So I've talked about, the challenges that public transport faces. I've talked about, how we address the bus specific challenges to ultimately provide an optimal route and an optimal timetable. And now I want to kind of get into a bit on the details about how it's implemented. So I previously kind of gave a high level overview of the inputs into the platform. So we'll dive into a bit more detail on that now. So as I previously mentioned, we've got that AVL data. So that's the GPS data coming in real time. We've got ticketing data, we've got schedule data, and then we've got other third-party data depending on the use case. So that all gets processed in a component we call Swift Engine, and then it's made available then to our downstream applications. So the data we deal with can come in a variety of different forms from a variety of different providers and in a variety of different qualities or different cleanliness. So the first part of the process is we need to extract this data from the different sources. We need to clean it, and then we need to transform it into kind of a common CitySwift structure so that's available for all of the next steps. That clean data then is transformed and it's joined in with the other data sources. And the resulting output, the master file, is then stored and it's loaded into our data warehouse. So we make really heavy use of, like our infrastructure provider is Google Cloud Platform. So we make a lot of use of their native tooling. So we have to process terabytes and terabytes of data every single day. So it's really important to have high performance data processing capabilities there. From an application perspective then, once the data gets into our data warehouse, so our data warehouse is BigQuery. So we use BigQuery for all of our analytical our analytical jobs, and Postgres for any of our transactional stuff. We make extensive use then of Python for any analysis work or any analysis workloads. And then our application logic is written in Kotlin. Then from a front-end perspective, we've got your single-page web app developed in React. And then for any kind of more bespoke or internal reporting use cases, we make use of Looker. So as you can see, kind of from a tech stack perspective, we use all of the modern kind of tooling for development, DevOps, etc. So the bit I haven't talked about in all of that is kind of the data science and the analysis piece. So we're a very data-intensive company, and all of our big roadmap items have extensive data science requirements. So for that reason, we typically begin with the data science spikes or those data science investigations before we do anything else. So before we look at any of the UI, UX elements, etc. So a lot of our exploratory work on the data science side of things is done up front. So we've a very heavy emphasis and a very heavy investment science and the R&D side of things. So as part of that, then we make use of a variety of different libraries, models, etc., depending on what use case we're looking at. So you can kind of get a feel for some of the things that are being used at the moment, and there's a bunch of other things for upcoming development work that we're looking at as well. So, and then finally, in terms of how we're structured, so we're structured in kind of two broad categories. So we've got kind of the infrastructure and the data team, the platform team, called the Thunderbirds, who look after Swift Engine. So they're the wizards who manage to clean all the dirty data, pull the data in from all of those disparate sources, etc., and make it available to the downstream applications. From an application perspective, then what we have is we've got cross-functional application teams, where we have a mixture of skills on one team. So we've got product managers, we've got UI UX, we've got test, we've got front end, we've back end, all on the single team. So you can have complete ownership of a story kind of end to end and a product end to end. So thanks to the work done by all of our engineers on the applications that we've been able to develop off their backs, we're able to provide services and solutions to operators and local authorities that improve transport, not only for the passenger, but also for the operator, the knock-on benefits at a city level, and ultimately all of this has global level benefits. And with all of this, we're able to back up, everything we say. So here's an example of, for one of our biggest clients, this is National Express. So we've been able to provide significant benefits to National Express as part of optimizing their routes and their network. So with our help, they've been able to improve the performance of their network by 12%. We've been able to do that in a way that hasn't resulted in additional costs. We've actually been able to reduce the vehicle hours, and ultimately, through the use of CitySwift, they've been able to, get a 3x ROI from what their spend with CitySwift is. So really significant savings. And it's important, when we look at these numbers, not just to think about it, the benefits from the operator. If you think of those performance benefits, every time you improve the performance of a bus service, there's elasticities around that. So that means your improved bus performance is going to attract more passengers. That means with more passengers on the bus, we have less cars on the road, we have less congestion at a city level, and ultimately less emissions at a global level. So we've kind of been able to deliver similar benefits across all of the people we work with. Okay, so that's a whirlwind overview of CitySwift and what we do from a passenger, operator, and a city perspective. So if anybody's any questions they'd like to ask at this point, please shout.
So one of the questions coming in, I'm not sure whether there's a bit of tongue-in-cheek in this one. Have you worked with Bus Air yet?
No, not yet. We'd love to work with Bus Air and love to work with any of the Irish operators. Our focus initially was around the UK, like I mentioned. So they're kind of the trendsetters really when it comes to high-performing bus networks. So anything that works well in the UK will work well globally. So we'd be confident if we can work with any of the Irish bus operators that we'd be able to provide significant benefits.
So one question I'd have, Gearoid, what are the biggest kind of challenges that you have in terms of delivering into the UK from here in Ireland?
Well, I guess we're lucky, William, that we've got really, really good relationships with the operators we work with. To the extent, it blew my mind when I joined CitySwift originally. So I joined at the start of lockdown. So everyone was working remotely. So we had a quiz every Friday, and sure enough, on those quizzes were the customers we were working with. So we've got an amazing relationship, and we've been lucky enough that there aren't too many challenges. Travel back and over is a bit of a pain, but ultimately it's been really good.
Super. Do you see a role for integrating real-time data from sensors, cameras, LiDAR, i.e. tech used in autonomous driving into helping to make more real-time decisions to change routes, etc.?
Yeah, absolutely, 100%. That's where everything's going from an industry perspective, and that's where we're leaning towards as well. So if you look at any angle, you look at how the buses themselves are developing. So more and more of this kit is being available in the buses themselves from the time it leaves the manufacturer. So in particular with the electric buses, they're being kitted out with a lot more of that technology. So as that becomes available to us as downstream data consumers, we're really keen to start using that.
Super. And is the work you're doing influencing transport policy in the UK?
It would be, yeah. So if we take some of the authorities we're working with, looking at those bus priority measures, etc. So the analysis that we do is informing bus priority measures in areas in the UK. Absolutely.
Kind of a technical question. You've got a really you're working with all of the latest tech stack and tools and technologies. What are the challenges that you see around that and on into the future as some of those may become less in vogue or whatnot?
Yeah, so I guess from an infrastructure perspective, one of the challenges we see coming down the line for us is just simply the geographical hosting of some of our infrastructure. So with the increasing adoption of GDPR clones throughout the world, there's more and more restriction being placed on where the data can be stored. So we don't have a lot of PII information on the platform, but we do have some. So one of the challenges for going to some of these countries where we don't have, there isn't a GCP data center in there, so being able to support that. So we do have plans in place on how we can do it, but there will be a bit of work trying to put that in place for us. So that kind of the GDPR combined with the restrictions about where you can host your data will be a challenge. Not unsurmountable, but yeah, we'll get over it.
And I suppose, have your operators become very dependent on the data and information that they're getting out of CitySwift?
Yeah, absolutely. So what we typically find is, I guess with any sort of use case where you try and introduce a new technology, initially, the adoption might be low. Then they start to see the benefits of it. We run, monthly workshops with them, and then over time, the level of dependence grows and grows. So for some of our operators, we might only have half of their routes on the platform, but pretty quickly they're at all of their routes on it because they can see the benefits not only in terms of performance, but then it's just their time. Like the analysis that we do would take them weeks to do for an individual route. We're able to get them results in minutes.
It's amazing. We have another one in here. How up to date is the demographic data that you use? Do you use demographic predictions?
So the demographic data in that example we're using comes from the mobile phone movement data provider. So they've got up to date demographic data there. It's nice to be able to use census data as well, but census data goes out of date quite quickly. So where we can, we use census data, but for that particular use case, we use the demographic data that come from the mobile phone data provider.
It's a really interesting. It's a really interesting use of AI and some serious amounts of data points there.
Yeah, it's very exciting, and it's great just being able to make a difference. It's cool to be able to see the technology you're creating, making a difference on the road and making a difference in the lives of everyday people.
For sure.
I see there's another question here from S. Edwards. Is your access to mobile phone network positioning information regulated by service providers? Yeah, absolutely. We don't have any direct access to that mobile phone data. It comes through the provider themselves, and they're very, very careful about making sure that it's all anonymized and nothing can be brought down to even 10 people. So it'd be nigh on impossible for us to do anything that's privacy sensitive there. So it's very tightly regulated.
Sure. And another one from Jerry Carthy. Can Google data used in Google Maps be used instead of the mobile phone data?
Potentially, yeah, potentially. So I guess, yeah, yeah, potentially. I guess there's a cost factor in all this. We've started with the mobile phone data, but yeah, absolutely open to using any better alternatives.
I suppose some of that mobile phone data is feeding the Google Maps data as well.
Yeah,
in terms of real-time traffic jams and whatnot. One from Marina Garris. Are you planning to break into the Asia market?
Yeah, hopefully, yes. Yeah,
yes.
that's on the cards. Yeah.
Yes. So, Rena, if you have any contacts in the Asian market, Garage, I'd love to have a chat with you. Another one in here from Michael Cooney. What happens if you lose live mobile networks due to technical issues or breakdown?
Yeah, I guess these things happen. You know, the bus will go through a black spot. They'll go through an urban canyon or what have you. So it is difficult to come across that. So with some of our data, you know, some of our predicted data, you know, let's say looking at live passenger counts, you know, or predicted passenger counts, they'd be able to get an estimate of, you know, how many people are likely to be on board. But you will still have a gap there when it comes to any of the real-time pieces if there's a breakdown.
And how critical are those real-time pieces to some of the decisions that you're making?
Yeah, so the majority of our decisions are, you know, aren't necessarily made in real time. So if you're looking at schedule information, so you know they're not as time critical. You know, they've got weeks or months to plan that out, which is good. Likewise, your bus priority measures, you know, that's kind of going to be an ongoing analysis as well. So for the most part, you know, it's not as critical if there's some sort of data gap.
One from D, I think it's more a statement rather than a question. It's a great local success story.
Brilliant, thanks, D.
So I suppose if there isn't any more questions, we might wrap it up. Garage, that was a really interesting insight into buses, probably my least favorite form of transport. I would definitely go for a walk or run or use the car or bike before hopping on a bus normally. But I suppose some of that is down to the past experience that we've had.
Yeah, past experience, and then like I guess the key question is when you look at where you are, like, is bus a viable alternative for you? And it just simply mightn't be. You know, maybe there isn't the investment, there isn't the frequency, etc. So yeah, you might be left with a situation where you have to take the car. I guess what we'd love to see is that where, you know, there is that investment made, that the right decisions are being made in a data-driven way, so that it could become a viable option for you in the future.
Yeah. Viability is the key to it.
Yeah.
Super. All the thank yous and the applause is beginning to run in.
Thanks whenever you appreciate your time. I know you're all very busy.
So I'd say with that, we'll thank you, Garage, for a really interesting and fascinating talk. Again, thanks to our sponsors. And there are another couple of talks left, so hop on over to the AtlanTec website and sign up for what's left of the AtlanTec Festival. And thank you all for